Welcome to this video. We want to work on two problems. One problem is this problem related to functions. We will solve it in first part. And in part two, we will solve this USACO problem, problem 2, December 2022. We will work on the ideas, we will define functions, and we will solve this problem in part 2. If you want to go to a specific part, and the idea here we use will be useful for other years, 2023, 2024, and so on, for USACO preparation for bronze part, silver part, gold part, and other parts. If you want to learn more ideas, want to prepare for USACO or AMC or AME or USAMO, and want to learn important ideas, feel free to send message to my WhatsApp number in the description. Problem says f of x plus 1 over x minus 1 equals x squared plus 2x plus 1 over x. Find f of x. Here we can all say that it is also equal to x plus 1 squared over x. And we can define also x plus 1 over x minus 1 equals y. So then I want to find x in terms of y and replace here. So if we cross multiply x plus 1 equals y times x minus y times x minus 1. And then I want to find x in terms of y. So how can I calculate x in terms of y? We should take all things that contain x to one side and other things to the other side. So here it will be x minus yx because 1 will be negative 1 minus y. So we can factor here x, 1 minus y equals to negative 1 minus y. So we can say x equals, if you divide both sides by, let's divide both sides by y minus 1. So we can also negate this one, or let me tell you something. We can divide first by 1 minus y, it will be negative 1 minus y. 1 minus y, then we can negate both numerator and denominator. So it will be 1 plus y, y minus 1. Now, in next step, we can say what? We can say f of this is y, so y equals x plus 1 squared. X is what is this? So it's 1 plus y over y minus 1 plus 1 whole squared over 1 plus y, or we can write y plus 1 over y minus 1. So it will be what? It will be y minus 1 here, y plus 1 plus y minus 1 whole squared if you use common denominator over y plus 1 over y minus 1. Negative 1 and 1 will be cancelled. It will be 2y over y minus 1 whole squared over y plus 1 over y minus 1. Okay, if you simplify, it will be what? 2y squared will be 4y squared over y minus 1 squared, and over this y plus 1, y minus 1. We can simplify this, or if it is a bit hard for you, you can write first fraction times reciprocal of the fraction in the denominator. Okay, so y minus 1 and this power will be cancelled. It will be 4y squared. This times this, which will be y squared minus 1. So we can change y to x. So f of x will be 4x squared over x squared minus 1. Now let's check. For example, if it is negative 1, x negative 1, here it will be f of 0. Let's check some values. F of 0 equals, here it will be 0, correct. For example, if x is 2, it will be 2 plus 1, 3 over 2 minus 1. 1 f of 3. By this formula, it will be 2 plus 1, 3 squared, 9 over 2. If we use this, f of 3 will be 4 times 3 squared, which is 9 over 3 squared. 9 minus 1, it will be 4 times 9. 9 minus 1, 8. So if you simplify, it will be again 9 over 2. Okay, always check your answer. Do not have careless mistakes. So it was part 1. Now let's focus on part 2. Read this problem, pause the video and read. And it is input, output. It is input, and we have these outputs and this. Let's first explain inputs and outputs to understand problem better. So here, let's consider first case. It says 5. We have 1, 2, 3, 4, 5 cows, and for example, the first one it's G, next one H, G, G. And if we consider a cow, this one is K for us. K is 0. So this one, let me tell you, for example, here N5. This one 5, 1. Let me explain for you this part. First, we have one. We consider two strings. First one main string. It is S. Now we consider function for the output. Say 1, 2, 3, 4, 5, 6. So this one wants G. This cow, it's G. So, and K is 1. It means that if G is here, or if the distance of G to this one is 1 unit, this cow can eat. So this one and this one. So we should place 1G here or here. Which of them is better? Obviously this one. Why? Because this one covers here, here, and here. But if you place G here, it covers only this one. Okay? So in general, it's better to place G here. Okay, so 1 unit like this. And it covers this if they are G. But because next one is H, so we place H 1 unit like this. Now, this H covers this one. Also, if it was H, this H covers this one. So, now next one. This G. The G here, we place the distance is 2, so it doesn't cover this. So we place this G here. Now, I will tell you, for example, if here we had H and this one G, we will place G here, and then at the end we will change this one, okay? So at first, we consider a string larger than main string. So if I want to explain only the problem is what? I place this G here, and this G covers this one, this H covers these things, and point means nothing, these two places. So we need what? We need 3. Farmer John needs to plant these 3 G and H. And here, let's check the output for second one. 3.GH.G. Okay, for this one, because the distance should be 0, so when you place GH, this one should be GH, because when here we have G, because the distance should be 0, if you place G here, it's not useful for this one, because it can move 0 unit. So it will be like this. So it will be what? We have 5 grasses, and Farmer John should plant 5 here. So it will be what? 5 and 8 things. This one 3. Let's check other inputs. This one, N is 5, K is 2. And the input is GHH, GG. 1, 2, 3, 4, 5. For this G, because K is 2, we know if we place G here, it covers this one. So this G covers this one, all to this part because K is 2. For this H, we place here by the algorithm that we want, and then it covers all of them. So the answer is 2 and GH point. GH point. Okay. Uh, we have also other outputs, but it seems that the algorithm of the output of sample is same as our algorithm. Now let's check next one. For this one, n is 5, k is 3. G H H G G G H H G G. K is 3. 1, 2, 3, 4, 5. This G, 1, 2, 3. You can place it here. And this H, you can place it here, and it will be okay. They cover all of them, so it will be 2, the output. So 2 and GH like this. Now let's check next one. N is 5, K is 4. So this one. GH GG. 1, 2, 3, 4, 5. Because K is 4, so G 1, 2, 3, 4. G. And now it covers all these G's. For this H, if we go 4 units to right, it will be here, H. Okay? But we know this place is outside of our range. So when it happens in our algorithm, I will explain. For you that we place it here or here, one of them is empty at least. For when K is at least 1. So we place H here instead of this point. We move it here. And in the code, I will explain completely. So again, the answer is 2 for this part. And our answer is HG. 3 points HG. And last one, let's consider these 2, 1, GH. GH, 2, 1. I place G here and H here by the algorithm that we want to use. HG. Okay, I will explain all these things. Now, let me explain completely my algorithm. Suppose, for example, we have G, G, H, G, H, G, G, H, G, 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 H, G, 1, 2, 3, 4, G, H, and for example, K suppose is 5. Okay. Now, when I want to place, I say, okay, for this G, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. Let me check 1, 2, 3, 4, 5. I place this G here. And we know it covers this one because K is 5. When K is 5, it means 5 less than that and 5 more than that. It covers all of them. So 1, 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5. It covers all these G's. Now we will see, okay, it covers this one, next one, H. Here, for this H, I place it 1, 2, 3, 4, 5 here. Let's see it covers up to which position. 1, 2, 3, 4, 5. Up to this word, it covers all these things. So, when we move, we can check each of them. We will see that they are covered. The first one that is not covered is this G. So you say 1, 2, 3, 4, 5, 6, 7, 8, 9. So you say 1, 2, 3, 4, 5 for this G. Okay, and it covers all of them. This one, this one, this one, and this. Next, we will see this H. Let me check 1, 2, 3, 4, 5. Suppose, for example, this one is G, this one is G, because I want to tell you an example that H is outside. So it happens like what? This G will be okay, this G okay. Now for this H, 1, 2, 3, 4. If we write algorithm like this, H will be here. Okay, and now what happens? I want to prove for example, if we don't consider, for example, N1, K2, always one of these two places are good. Also, maybe we have both H's and G's here. Okay, in that case, also I want to say these two places are good. Here, I will see this one is empty or this one because it is outside our range. The first one that is empty, you place this H here. And if I want to tell you an example that they will be outside, for example, G, G, H, H, and the problem says K is less than or equal N or not, less than or equal N minus 1. Okay, let me find an example that it covers last thing. So, example, suppose 1, 2, 3, 4, 5. So I place G here, then we have G in this position, H here, H in this position, 1, 2, 1, 2, 1, 2. Okay, here it's not important, G, H, G. Suppose K is 2, okay? For this case, and our input is this. Now let's place 2, 3, 4, 5, 6, 7. For this G, I place 1, 2 unit here, and it covers this one, this one, this one. And for this H, I place here, it covers this one, 1, 2. Okay, and then we continue, it covers all of them. Now, we know it is outside for this G. 1, 2 here, we have G. For this one, we have H. So, because these two things are outside, then these two places, so you can say first one here, G, and second one here, H. Okay? Now, let's explain. So, at first, we should check special cases if K is 0. If K is 0, for example, if the string is this, anything, S0, S1 to Sn minus 1. If K is 0, our function or our output will be again same thing, S0, S1 to Sn. If n is 1, the string will be S0, and f will be exactly same thing, will be S0. So now we can conclude what? We can conclude n is at least 2 and k is at least 1. Now if I want to explain this part completely, I say, okay, let's consider our first string is this, 0 to n minus 1. And suppose our function or output is from what? Let me write it here as 0 to n minus 1. And f is what? Or our output is 0, n minus 1, n minus 1 minus plus k. Okay? And then we can say what here also we can use this, and let me show next one like this. Okay. Now, next part, we can say what? We try to read elements in S. Okay. Now we say what? We say okay. And we have two variables. Cover G, cover H. Well, let's write this. Cover G, cover H, and at first both of them are -1. Now we start from string S, okay? And then in each case you should reset all our variables because we have some test cases, okay? So the first one, we will see is it H or G, okay? Now if it is, for example, G, the first one, you place this in case 1. Okay, so f of, you have a 4, for example, I from 0 to n minus 1 for s. Then you say what? If s of I is not covered, means what? This part, we have something, for example, when we place G, it covers from this. Cover G will be, let me explain for you, this part will be what? If it is G, for example, and you place G here, then cover G will be, let me erase this one to K after that also. It will be 2K, okay? So when SI is not covered means what? Means, this one let me explain, if SI is G, then cover G is less than I, it doesn't cover this. Or if SI is H, here let's write coverage like this. Cover H is less than I, means it doesn't cover I. If it is not covered, we should consider f of I plus k equals what? Equals SI. And the cover will be what? For example, it depends on this. Cover G will be I plus k. It is for the case if, let me write it here. You should check if SI is G. If SI is H, cover H will be I plus k. Okay? And then you update these things, and again you check and write all these things. Okay? And you fill F. Now at the end we have one thing. You should check F, that what happens for F. Let me check for F. At the end you should check here. N. If F of, for example, from N to N minus 1 plus K is not empty, so you can check, for example, how many variables are there. If you have 2, then you can fill in n minus 2 and n minus 1. And let me tell you something. If, for example, here, after this part, it is f, this one is n minus 1, and after that, for example, here we have g, here we have h. I want to say that the last two things are not empty, and we know n is at least 2. In the beginning, I said these two should be empty. Why? Because here, for example, if we have G, it means it covers all these things. So why you added this G? Means K plus 1 after this, right? So, but because we have G, we covered this one. So if you have G and H, both of these two things will be empty. Okay, one case is this. And if we have, why this one is empty? Because suppose, for example, this one is G. So when you placed G here, it means what? Something placed here. It means it is not covered, but this G covers this one. If it is here, it is 0. For K 0 also it covers. If G is here, for K 1. So when G is here, means K is at least 1. Also in the beginning, I've checked K 0. Okay, so we will see that it's not possible that these two things, one of these two things be filled. Both of them are empty. Now sometimes we have one variable here, for example, G here. It's n minus 1, n minus 2. Now I want to say that one of these two things are empty. Why? Because if both of them, and then I place g in one of them, and it will be okay, because k is at least 1. Why? If both of them are filled, h is not possible, because when you place h here, it means h at least 1, it also covers this one. You don't need to add h again. So if both of them cannot be h, also both of them cannot be g, because when you place g, this g will be covered. One of them also cannot be g. Why? Because if this one is g, k is at least 1. It covers also this one, so why you place this g here? Because it covers all these things. Okay, so for example, if it is before that, means k is greater than this. It will be covered by this g. So this one cannot be g. Similarly, this one cannot be g. Both of them, which also we said not possible, because k is at least 2. K is at least 1. We've checked k 0 in the beginning here. So we can say what? We can say that we have always one place for these two things. If we have two things, both of them are empty. If you have one thing here, g or h, at least one of them is empty. Okay, so at the end you check. If it is not empty, if you have two things, place them in n minus 1, n minus 2. If one of them is filled, place that one is one of these things. First check n minus 1. If it was not empty, place in n minus 2. Okay, so it was the algorithm here. We've explained completely. Let me also show you the code. The code is this one. Here, I explained main CNT into I0 to T, sin n and k, then answer of n and k. Then you go here, answer, then PR is our f, okay? From 0 to n plus k plus 10, something like greater than that. We need only up to n plus k less than or equal n plus k minus 1. And then I've checked if k is 0, it will be this. If n is 1, it will be this. So here, we know that n will be at least 2 and k will be at least 1. And then I checked if it is 0, g. I've considered two arrays for g and h. I consider indices, then cover, like the thing I told you, cover g, cover h. It covers all these things, and then I place h places, g places the in our functions, f the indices. I've considered these things. And then at the end also, if g place means you place g in array f, or here pr, the index is greater than equal n. Then I set p n minus 1 or n minus 2, both of one of them at least empty you can place. And then you check h. If h is outside our range, then you can place it in index n minus 1 or n minus 2. And then you print this. And then function print is what? You print point g and h with respect to things that we've calculated by our algorithm. Okay, if you want to learn more ideas like this, want to prepare for USACO, bronze, silver, and other parts for 2023, 2024, if you want to prepare, feel free to send message my WhatsApp number in the description. Let me tell you, homework. Homework is what? Let me write it. Because this problem was dynamic and related to recursive sequence, let me tell you a problem to solve. Suppose, for example, we have a 2 by n, and each step, we can color some cells, okay? We don't want, there is no adjacent cells. There is no adjacent black cells. And adjacency means what? Means with common edge. And each cell is black or white. We can say each cell is black or white. And how many ways are there? AN is number of ways that we do something like this. So for example, for 1, A1 is what? White, white, black, white, white, black. A1 is 3. A2 is what? Empty. If we color one of them 4 ways, 2 of them 2 ways. So A2 is 7. Find recursive sequence for AN. Okay. AN is what? Find recursive equation for this problem in terms of an minus 1, an minus 2, an minus 3, anything like that. And comment your answers right below this video, because look, dynamic problems in USACO like this, related to functions, related to recursive sequence problems. Sometimes in 2D, sometimes in 1D. Okay, if you want to solve more problems related to dynamic, recursive sequence and something like this, as I said before, feel free to send message to my WhatsApp number in the description. Okay, thanks for watching this video. Have a good day. Bye.